Hello and welcome everybody to another exciting, fun-filled, action-packed answer key video. Today, we will be going over the work, power, and energy practice number 2 video. You can see there's all of the answers right there, but I'm going to take you one step further. We're going to actually work through these. That way you have an understanding of the problems at hand, and that way you can see how to work through these. All right, I'm not just going to throw the answers at you. We're going to go through each one step by step. So without further ado, let's jump right into these. Okay, so number 1, run out of gas. Get it? Run out of gas. I crack myself up, even though I am the only one here laughing at that's not true. My fiance is here, but she does not laugh at my question, my jokes. I mean, I think I'm funny. Don't you? All right, probably not. Anyway, Renata Gas is out with her friends. Misfortune occurs, and Renata and her friends find themselves getting a workout. They apply a cumulative force of 1080 newtons. So this is number 1. We're looking at a force of 1080 newtons. Let's see, to push the car 218 meters to the nearest fuel station. The distance is 218 meters. We don't use big M, we use little m for meters. Meters, let's see. They complete the task in 1 hour. Time is 1 hour, but we know time really isn't 1 hour. Well, it is, but we don't like hours. We like seconds. So 1 hour is really 3,600 seconds. Determine the work done on the car and the power with which the girls pushed. Well, we know work is equal to FD, so let's just do that exactly. Force, 1080, times the displacement, 218. Multiplying this out, we get 235, 440 joules. That is our work completed. And we want to find the power. So power, plug and chug, right? Power is work divided by time. Remember, your equations are right up here, guys, right? Right underneath the golden light. Because it's an idea, so it's like, bing. Okay. Again, I think I'm funny, and that's what matters. So we're going to take our work, 235,440, and divide it by our time. Remember, your time is not 1 hour, but 3,600 seconds. 3,600 seconds. And this gives us a power of 65.4. Do you remember the units for power? Yes, you over there. Are they watts? They are watts. Very good. Smart guy in back there, right? Smart guy. So we have joules and watts for work and power. Remember also that joules is the unit for energy, potential and kinetic too. So remember how work and energy are essentially the same thing. All right. So that's number 1. Let's move on to number 2. Number 2. Hans full. Get it? Hans full. Seriously, please laugh. That's all I have. Just please, a chuckle. A chuckle wouldn't hurt. Hans full is pulling on a rope to drag his backpack to school. Oh, guess what? We are going to leave this one out because it deals with angles, and we're not going to deal with angles. So number 2, we're going to drop out. We're not going to do number 2, okay? So let's skip to number 3. Lamar Grant, U.S. powerlifting star, became the first man to deadlift 5 times his own body weight in 1985, 2 years before your old teacher here was born. Deadlifting involves raising the loaded barbell from floor to a position above the head with outstretched arms all the way up to the top. Determine the work done by Lamar in deadlifting 300 kilograms to a height of 0.9 meters above the ground. So he lifted a mass of 300 kg, a distance of 0.9 meters above the ground. So remember, work is usually FD. But what do I always say? Work and what are the same? Work and energy, right? Energy. So if we can't find the work done here using our traditional work equation, force times displacement, let's use our energy equation. We're lifting something up. So when we lift it up, do we give it kinetic energy or do we give it gravitational potential? Yes, you. Gravitational potential. Very good. Gravitational potential energy. So let's solve for the GPE, right? Remember, GPE equals mgh. We have a mass of 300. We have a gravity, that's a constant. We know what that is, 9.8. And we have a height of 0.9 meters. So we're finding the work, but we're like using a backdoor way to find it. We're actually finding the GPE, which is the work, right? So the GPE that it possesses way up top here was the work that was done to lift it up. Multiplying all of these out, we get 2,646 joules. Very good, everybody, very good. All right, questions. I'm so used to saying questions. Hopefully you don't have any questions. And if you do, hopefully you email me those. All right, let's move on to number 4. Let's see. Number 4. Okay, number 4. So, number 4, while training for breeding season, a 380-gram male squirrel does 32 pull. Yo, that is one jacked squirrel, right? You just imagine that little squirrel doing like 1, 2, 3, 4. That squirrel's got to be ripped. So, a 380-gram squirrel. So the mass is 380 grams. We don't like grams, right? We want kilograms. So what do? Move the decimal how many places? Come on, louder. Louder. Okay, not that loud. People are gonna wonder why you're yelling in your house. Easy, easy. You're right, 3. So this is really 0.380 kg, perfect. He does 32 pull-ups in a minute, right there. That minute is how many seconds? 60 seconds, okay, 60 seconds. Displacing its center of mass by a distance of, so we have a distance, displacement is 8.5 centimeters. We don't like centimeters, we want meters. How many places you move in that decimal? 2, right, 1, 2. So 0.085 meters. Determine the total work done by the squirrel while moving upward 32 times. So we want to know his total work that he did 32 times total, okay, over the 32 reps. So that's what we're looking for first, and then we're going to find out the power. So let's find the work that he does. Work equals FD. However, we don't have a force. But remember from the past problem, right? Force is really just, work is really just energy. So let's find his gravitational energy because he's lifting his body up. He's giving it height, right? So GPE equals mgh. His mass is 0.380. Gravity is 9.8. And the height is 0.085. Multiply those out, and you get 0.316 joules. Okay, that was the work that he did for 1 rep. How many reps did he do? 32. 32, right? You didn't think I knew how to speak Spanish? Ha ha ha. A little bit, just a little bit. So What do we have to do with this number? Multiply it by 32, because we want to find out how much work did he do total. When we multiply this by 32, we find out that he did 10.13 joules of work. He did 10.13 joules for the 32 reps, okay? 0.316 for each individual rep. Now, we want to find out the power of the squirrel. We need to find out his power. Okay, it's been a long time. I'm held up in my house. I need to make me laugh somehow. Hopefully I'm doing the same for you. So we need to find his power. To do that, we take our power equation, work over time, take our work, our total work, 10.13, and we divide it by the time. How long did it take him? 1 minute or 60 seconds. So 10.13 divided by 60, 10.13 divided by 60 is 0.169. 0.169 watts. Okay? 0.169 watts, that is his power. Excellent job, guys. Excellent job. You all are doing very, very well. I'm very impressed with how hard you guys are working. And if this is your first video that you're watching and you're saying to yourself, I'm not really working that hard, and you're laughing at me right now, well, hopefully you're going to start working hard. Okay? So I know you all are very capable and you're doing a good job. So, all right. Enough of that good teacher talk. Let's continue moving on. So we still have 5. We still have 6. We are going to drop out number 7. So we have 5 and 6. And then we have, we're going to drop out 7. We have 8, 9, 10, 11, and 12. All right. So let's get to going with number 5 and 6, and then maybe we will leave 8, 9, 10, 11, and 12 for another video. So we have 2 more in this video, guys. Let's do number 5. So for number 5, during the Powerhouse Lab, Jerome runs up the stairs, elevating his 102 kilogram body, mass 102 kilograms. He elevates his 102 kilogram body a vertical distance, displacement of, or height, right, of 2.29 meters. Let's see, 2.29 meters in a time of 1.32 seconds. 1.32 seconds. A, determine the work done. So work equals FD, but wait, we don't have a force. So we need to use our energy equation again. So please remember that this is also equal to GPE, which is equal to mgh. So let's just say work equals mgh. We've done this before a couple of times. Mass 102 times gravity 9.8 times height or displacement 2.29. Doing this out, we get an answer of 2,289 joules. Now we want to find his power, or the power that he generated. We just take our power equation, we take our work and divide it by our time. 2,289 divided by the time, which was 1.32 seconds. In doing this, it's 1,734.2 watts, and that is our power. Now again, think about this. I know we've talked about this in the original notes video, but the less time he takes, the higher his answer would be. Think about this, right? If he only took 1 second, then our power would be 2,289. The more time you take, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds, the less wattage you're gonna have, the less power you're gonna have. So you're always more powerful if you're doing something in less time. Think about that, okay? All right, guys, last one for this video, and then I will link up at the end of this video another video, and to go to the rest of the answer key. Okay, number 6. A new conveyor system at a local packaging plant will utilize a motor-powered mechanical arm to exert an average force of 890 newtons. Force equals 890 newtons to push a large crate at velocity of 0.6 meters per second. Hey, something a little different. Sweet. Determine the power output required for such a motor. We want to determine the power. All right, how do we do this, guys? Well, we know power equals work over time. All right. Do we have work? Well, we know work equals FD. So let's replace that. FD over T. Okay, y'all see what I did there? I took work and I just substituted in the equation, FD. So now instead of work over time, it's FD over time. Now let's look even closer. We have a force, check. Do we have a displacement over time? No. But what is displacement over time, guys? D over T, meters per second. That's a velocity. So we have a velocity. So essentially what this is it's force times velocity. 890 newtons times 0.6 meters per second. It's the same thing. Newtons meter per second. Newtons meters per second. We just found power by multiplying force times velocity. And that gives us 534 watts. And that, everybody, is the end of this video. Make sure you guys click on the link for the next video. It will be right here. So make sure you click on that. Join me again when we go over the next couple answers and finish out this sheet. Have a great day, everybody. I'll see you all in the next video. Mr. F, out.